Hey folks, how's it going? Everyone hanging in there? Last session for the day, I think. Last session for the first section of the conference, I think. Apologies for reusing the Forging Ahead pun. I think there was actually another talk yesterday also called Forging Ahead. I think at this particular point in the conference, everyone is probably feeling fairly forged out. Forge some new friendships, ready to forge a new path at the workshops tomorrow. Anyone sick of hearing the word forge? No, I'm always excited to talk about forge. But today we're actually going to be talking about forge and connect and forging pathways between them. So as Mel mentioned, I'm actually in a new role as of a few months ago. I'm an ecosystem solution architect at Atlassian, which is a bit of a made-up title. We're still trying to figure out exactly how this function is going to work. But I'm at the moment spending a lot of my time helping partners, both solution partners and marketplace partners, and increasingly enterprise customers be successful with the Forge platform. And one of the areas that I've been focusing a bit on is helping some of our larger partners plan and execute migrations from Connect to Forge. And on that journey, we've come across a bunch of patterns that we think will be helpful for the broader community when it comes to adopting Forge components incrementally from Connect. And that's what we're going to be talking about today. So I mentioned I've just moved into a new role. I've actually been at Atlassian for a little over 18 years. I started as a Jira developer around about the awful shade of yellow stage of Jira's lifestyle. So I think it's about Jira 3.2, I think was my first release. But I spent the last decade or so working in and around the ecosystem. So I was part of the original Atlassian Connect team that shipped Atlassian Connect 1 around about Atlas Camp 2013. And I was also the founding engineering lead for the Forge platform back in 2019, which now Daniel Wester, Daniel Wester does spend a lot of time on Forge as well. Daniel Winter is the engineering lead for the Forge platform. He's around camp as well. I'm sure you've run into him. So I've got a lot of content, so we might just jump into it and see how far we get. Hopefully I've got a bit of a grace period since it's the last period of the day. So, as we announced back in October, all new extensibility is going to be being delivered on the Forge platform. So that's one of the good reasons to start thinking about how to start adopting Forge modules. Already today, by onboarding your Connect app to Forge, you'll be able to start to implement things like Rovo agents and actions, leverage new UI modules like custom fields in Jira or context menus in Confluence. And you'll also be able to be prepared for upcoming exciting modules like automation actions, which we're very excited about coming to Forge. It also gives you the opportunity to start migrating existing functionality over to Forge if you so choose. One reason you might want to do this is if you want to delegate hosting customer data over to Atlassian by using one of Forge's storage offerings. Or you might want to start building new features that you have planned on Forge rather than on Connect to avoid needing to migrate them later when those Atlassian Connect modules are deprecated. Or you may want to jump in with both feet and start looking to rebuild your app entirely on the Forge platform in order to start working towards that runs on Atlassian badge on Marketplace. Now, fortunately, whatever your intent is, the first step towards adopting a Forge manifest is pretty straightforward. We saw a quick demo of the conversion process in the keynote, so I'll walk through this section fairly quickly. But let's imagine you have a Connect descriptor with a collection of modules defined. And imagine you've built a web application on Atlassian Connect Express. You can also consider Atlassian Spring Boot, the functional equivalent for these slides. And you've assigned a set of endpoints for those Connect modules. As you saw in the keynote yesterday, the first thing to do is to run the Connect to Forge package, which sucks down a copy of your descriptor and converts it into a Forge manifest for you. Now, what this does is faithfully reproduce all of your Connect modules in Forge's YAML syntax, rather than Connect's JSON. And once you deploy the Forge version of your app, the Forge manifest becomes the source of truth for managing your Connect modules going forward. Now, this step doesn't actually publish a new version of your app to the marketplace. So that's a kind of an important point, because it means that right now you could go and experiment with this process. You can even deploy a new version of your Forge app using the Forge deploy command, and it won't impact any of your customers. So it's very low risk to take that step. Now, at this stage, some of you may have a few questions or concerns about taking the plunge into Forge. One of the common ones that we get is, how are your existing Connect modules impacted? And the answer is they aren't. So Forge delegates the actual rendering and handling of those modules to the Connect platform. So that means your Connect web app will still continue to service webhooks and render iframes as usual. So the customer experience of your app won't change at all. Another common question is, will converting your descriptor impact your marketplace listing? And the answer is, again, no. Until you've actually gone to the marketplace and published a new version and specifically selected your Forge app, it won't impact your marketplace listing at all. So you can experiment as much as you like until you feel comfortable enough to go and publish a new version. You can also continue to publish new Connect versions of your app before you've published that version as well. Now, another common question is, what happens when we publish a Forge version? So when you actually publish a new version of your app, the customer experience is pretty similar to a new Connect version of your app going out. At the moment, it's a major version upgrade, but as we mentioned in the keynote yesterday, that's very, very soon going to be a minor version upgrade. And so even once it's a minor version upgrade, if you do want to perform a staged rollout, you can. By default, it will roll out over a 96-hour period after that version becomes available. But if you want to just allow a list to a certain set of customers or test sites first, you can do that as well. So we can support a staged rollout if you want that extra level of confidence. We can also, in the event of an emergency, roll back, although this is very unlikely to need to occur, particularly if when you publish that version, it's just if it's just a converted manifest and you haven't made other changes, then that's typically very low risk. So, is there any reason not to register on Forge? And the answer is no, with a very small asterisk. And that very small asterisk is because, actually, sorry, I thought I'd update this slide. So major version upgrades aren't going to be a problem anymore. Data residency realm pinning is not a problem either. So most of our partners that support data residency implement realm pinning, which means that a customer can pick which region, the data is pinned to the parent region of the product site. If you've gone the step further and implemented realm migration, then that's not yet supported by Connect on Forge. That is coming. I think there's something like 46 apps on the marketplace that are in that category. That's basically the only cohort of apps that we're aware of that shouldn't be going through the Connect to Forge process at the moment, but that will be coming very soon as well. Does anyone else have an app that supports realm pinning? Okay, well, there's a few people, maybe five in the room. All right, well, thank you for coming anyway. Hopefully you'll take something from this session. For everybody else, you can go type the Connect to Forge process right now if you like. All right, so we have a Forge manifest. Let's take a look at how to actually go and adopt some Forge modules and use them with our existing Connect application. So there are three general patterns for implementing a new module with a Connect backend. Now, the first is the simplest. Just like a native Forge app, you can go and implement it as a Forge function. So this works okay if the function is standalone and doesn't need to communicate with your Connect backend. Now, if you do need to interact with data or functionality that's being served by your Connect web app, then there's a couple of different patterns you can use. One is to implement new modules using a technology called Forge Remote. I'll be doing a bit of a deep dive on in a second. Now, these allow your existing Connect web application to basically act as a backend for Forge UI modules, or also to process Forge events. So you can actually skip the Forge FAS or functions service entirely. Now, as I mentioned, we'll talk a little bit about how Forge Remote works. One of the cool things, if you're using Atlassian Connect Express or Atlassian Connect Spring Boot, we've actually built support for Forge Remote into both of those frameworks. So you're actually already running a Forge Remote application if you're using a modern version of either of those. So the third approach is a hybrid approach. And there's a few areas where we're specifically going to be recommending this. And so this means binding your Forge modules to a Forge function, and then using using a special command called invoke remote from your Forge function to talk to your Connect backend. So one of the features of Forge remote is the ability to make requests out to endpoints being served by your Connect app. Now, the best approach to take for a given module depends on the degree of interaction that module is going to need with your Connect backend. So before we look at individual modules, we're going to do a little bit of a primer on Forge remote. When you convert your descriptor to a Forge manifest, one of the new entries that gets added is your app's base URL in a section called remotes. Now, Forge remote is conceptually similar to Connect's JOT-based authentication or JWT-based authentication, but it differs in a few important ways. So when the Forge platform invokes a remote endpoint, we issue a thing called a Forge invocation token that gets passed along in a header as part of the request. So going forward, I'm going to refer to that as a FIT and a JWT token as a JOT. Now, we only send FITs for Forge modules. Your existing Connect modules will continue to receive JOTs even after you've registered on the Forge platform. So while similar to FITs, while FITs are similar to JOTs, they are superior in a few different ways. In fact, I was sitting next to this young, strapping, I assume he's a junior developer fresh out of university, yesterday during the keynote. And he mentioned that Freddie, one of his developers, had been preparing for the Forge workshops. And so they went and checked out Forge remote. Because they were going to go and migrate their app over to Connect on Forge and Forge remote during the workshops. And then it turned out they actually managed to go and migrate to Forge remote in the couple of days before camp. And so now they're going to have to do something else during the workshops. Now, Daniel, as I'm sure you're all aware, is very security and privacy conscious and appreciated some of the finer points of the improvements we've made to the authorization and authentication protocols with FITs. So we'll jump into those right now. So the first reason that FITs are kind of cool is that authentication is now stateless. So with the JWT signing protocol, I'm sure you all know, we issue a shared secret that gets delivered to you as part of the installation lifecycle of the Connect app. In Forge, there is no shared secret that gets shared as part of the installation payload, and you no longer need to store any secrets at all in your Connect backend. Instead, the FIT is signed using a private key that's private to the Forge platform. And then your app can verify the signature from that request using a public key that we publish in a well-known location. So that is a protocol called JSON Web Keysets, or Jukes. So we've got FITs, JOTs, and Jukes. And as I mentioned before, Atlassian Connect frameworks both support verifying these automatically, so you don't have to implement anything yourself. If you've rolled your own Atlassian Connect client framework, then there is really good library support across basically all popular languages for Jukes as well. So it's not too hard to go and implement that yourself. So just like the JOT, the FIT contains a bunch of contextual metadata about the Atlassian site that triggered the invocation, your app and the installation, and the module that triggered the invocation. However, you notice that one thing that is missing compared to most Connect invocations is the client key. And that's used in Connect as the primary identifier for the app that your site is installed into. So in Forge, client key has actually been replaced by two separate identifiers with quite different semantics. So we have the cloud ID, which some of you will probably be familiar with. Is anyone already storing the cloud ID as part of their Connect app? Okay, a few people. Well, the cloud ID has actually been around for quite a while, but it's only recently been formally included as part of, so it's sort of publicly exposed. So the cloud ID actually identifies the site and is stable across installations of your app. And the installation ID is a unique identifier that gets generated every time the customer installs your app. So if they install it, and then uninstall it, and then install it again, you get a new installation ID, but the cloud ID stays the same. So whether you want to persist data externally against the installation ID or the cloud ID depends a little bit on the semantics you want to have around data retention across uninstallation and installation. It's quite a complex topic, so I'm not going to go deep into that right now, but if anyone wants to discuss that more during the workshops or tonight, that's totally fine, we can do that. So once you've registered your Connect app on Forge, we also start sending the installation ID as part of the Connect lifecycle hook. So you can actually go and read that installation ID in your existing Connect app as well if you want to start binding data together there. There's also a special unauthenticated API available at every Atlassian, Jira, and Confluence site. At _edge/tenant-info, which just gives you the cloud ID back. So if you want to go and translate a base URL into a cloud ID, you can hit that at any point in time. You can see lots of people taking photos, more than welcome to. Also happy to share the slides. There's a crazy amount of diagrams. So no worries about it. I think we're also recording it as well. So yeah, as I mentioned, depending on your app's data retention policies, you need to have a little bit of a think about how you want to store that data, or you probably want to store both, I would say, so you can understand the semantics about how your app installation for a particular site changes over time. We also embed all of the license information in the fit as well, if you need to compare that back to the any of the license identifiers you get from Marketplace. Again, if you're using Atlassian Connect Express or Spring Boot, you don't have to worry about any of this. It's all handled for you. So there are a few different ways that you can invoke your Connect remote from Forge. You can do it imperatively from a Forge function using the invoke remote package from the Forge API package. So this makes it really easy for your Connect app to effectively expose APIs and data to your Forge app. And it also allows your Connect app to ingest data from Forge into your own remote storage if you need to do that for your purposes. Or, for many modules, you can actually skip the Forge function entirely and specify an endpoint. Now, if you do this, you actually skip the Forge function, and instead of, and we basically marshal up the arguments for the function and pass it straight to your endpoint via a web request instead. So in some cases, your Atlassian Connect app may need to call back into the Atlassian product APIs. Now, since you're really a Connect app, you can just use your shared secret to authenticate the API requests if you like, but you might want to start migrating away from shared secrets to use Forge Remote bearer tokens instead. So Forge Remote also lets you do inbound authentication into the product APIs. So bearer tokens are more secure because they're more tightly scoped. So Connect's scopes are quite broad, read, write, delete, admin. With bearer tokens, they're actually specifically scoped. Well, you can make them a little bit more tightly scoped if you like, although we do also support the broader Connect scopes in Connect to Forge apps too. Also, bearer tokens don't allow you to impersonate users unless you specifically request them to. So there is a little bit of a, what's the word for that? Well, yeah, it's like, has a slightly tighter identity binding than the shared secret does. They also give you access to Forge-specific APIs like Forge Storage. So if you want to use Forge Storage from your remote Connect app via the API, then you will need to use one of these bearer tokens instead of your JOT. So unlike Connect, where you can sign your own authentication tokens using a shared secret, the Forge platform actually sends bearer tokens to you as a header on the Forge remote request. But as I mentioned, for security, we don't actually send you this token unless you specifically ask for one. So to register to receive a Forge bearer token, you simply add an auth section to your remote configuration in the manifest. And so there are two different types of tokens. One is an app system token that lets you authenticate as the app's service account or bot user. And the second is an app user token that allows you to authenticate as the context user who triggered the invocation of your module or the event. So I realize this is pretty dense content for the last session of the day. Hope we're following along okay. Happy to recap any of this afterwards. Everyone following along all right? Yeah, getting some nods? Okay, good. All right, once registered, bearer tokens are passed to your remote service alongside every fit in a separate header. And then you can simply use those in the authorization header when you make requests back to the product API or one of the Forge APIs like Forge Storage. All right, so now you've got a bit of a handle on the Forge remote protocol. Let's take a look at actually using this to create some patterns on top of some of the Forge modules that we support today. Now, In this section, we're going to be looking at eventing, and specifically how to make use of Forge triggers, queues, and schedules from your existing Connect app. Then we're going to take a little look at migrating over user experiences to custom UI or UI kit. And initially, I did want to cover data migration in this presentation as well, but we're already at like 80 slides, so it's getting a bit ridiculous. So I promise I'll create a follow-up video where we talk about data migration. Or Brendan gave a great talk earlier today about Forge storage options as well. Both of these are going to be published on the Atlassian Developer YouTube channel. If you're not already subscribed, you should definitely check it out. We have great sessions from all sorts of folks across Atlassian. And we also have like regular, like once or twice a month, we do like live coding sessions where we get folks from the Forge team or the developer advocacy team. So what do the YouTubers say? Like, subscribe, hit that bell. Please do. All right. So let's take a look at some of the different technologies commonly used in Connect apps and their Forge equivalents. So for this section, I want to play a little game. Can anyone tell me what the Forge equivalent of a webhook is? Trigger. Yes. Okay, so we have two types of, actually we have a whole bunch of triggers in our Forge. Specifically, webhooks, as classically used in Connect, used to subscribe to product events and app lifecycle events. In Forge, we use product and lifecycle triggers. They're basically a function that gets invoked with an event payload, similar to a webhook, but not over the web. We also have, so Connect doesn't really have special support for any kind of cron or scheduling. But if you are using cron jobs or schedules in your Connect app, what would the equivalent be in Forge? Schedule triggers, yes. So schedule triggers are another trigger type that lets you run on a schedule. And then what if you had long-running tasks or queues, or if you're using SQS in your Connect app? What would the Forge equivalent be? Anybody? Async tasks? Yes. Consumers or async functions. Now, I tend to use these terms equivalently because they are actually the same module in Forge. You just kind of use them for different things. If you're using an async task just to get a 15-minute extension on your function, then I call it an async function. If you're queuing up a bunch of jobs and then consuming them for the queue, we tend to call them consumers, but they're actually the same module. We'll look at those in a sec. So we identified that a trigger is conceptually similar to a Connect webhook. And when an event occurs in a product, or if your app is installed or upgraded, the corresponding trigger module will be invoked for your app. Now, one unfortunate limitation with the Forge platform at the moment is we don't have a Forge uninstall event yet. That will be coming. But for now, you'll probably need to, if that's important to you, then you'll probably need to continue using the uninstall webhook in Connect. So you won't be able to fully migrate over just yet. In a native Forge app, triggers are typically bound to functions, with the event payload being passed to the function for processing. But another way to integrate is to use the invoke remote function that we looked at before. So you can call out from your function into a remote service. And yet a third way is to define a specific endpoint, which I mentioned before. This is the actual syntax for it. You can actually, so in your Forge manifest, you have remotes, which defines the base URL of the remote service, or in this case, your Connect app. And then you can define a set of endpoints, which are basically endpoints with paths that sit underneath that remote that you can then invoke using the invoke remote command, or bind to a particular module. So in this case, instead of a function reference in our trigger, we've got an endpoint reference, and it's going to pass that payload directly to them. Now, sometimes you might want to go and just specifically specify an endpoint, but I'd argue most of the time, at least for moderately complex apps, you probably want to route it via the Forge FAS rather than directly specifying an endpoint. And that's because there are a few differences between Forge events and Connect webhook handling. Now, the first is that the shape of the data is a little bit different. Connect webhooks tend to be fairly verbose when it comes to including data objects. So these have been a bit challenging for the product teams to maintain over time as we've kind of decomposed Jira's backend. We actually have like separate giant microservice. Yeah, not really microservices anymore. We have like a separate Jira issue service, and then we have a separate, Jira front-end monolith, and actually trying to assemble all of that data is quite a complex and slow process. Plus, as an Atlassian Connect consumer who doesn't love getting a Jira issue created webhook with several terabytes of null custom field values. So in Forge, the events tend to be a little bit more anemic, but then they include identifiers that you can go and use to fetch more data if you need to. The second is that event filtering works a little bit differently in Forge. So in Jira, you can filter Connect webhooks using JQL queries. In Forge, we use the more versatile issue expression language, which you may be familiar with if you've used workflow modules in Atlassian Connect, for example. But it is different, so you'll need to port over to that new syntax. And another subtle difference is that retries work a little bit differently. So in Connect, we'll attempt to send a webhook to you up to 5 times at a random interval between 5 to 15 minutes each time that fails. So if we don't get a success code back from your webhook endpoint. So that means a Connect app can be down for a maximum of 25 minutes before you risk starting to miss some events. In Forge, a trigger function, when it's invoked, you can actually throw an exception and say, retry me after a period of time. And you can do this up to 4 times. Each time you do it, you can specify an interval of up to 15 minutes. So that means you can suspend event processing for up to an hour if the remote that you're trying to talk to is down. However, if you specify a remote endpoint for a trigger, rather than going via the FAS, the retry interval is actually fixed at 60 seconds. So that means that if you do specify a remote endpoint, it can only be down for a maximum of 5 minutes before you start risking missing events. So one way to overcome some of those differences in event processing between Connect and Forge is rather than just passing events straight to an endpoint, if you have a function that mediates passing the events to the remote. So this gives you a lot more flexibility in how those events are handled. So you could, for example, attempt to invoke the remote, and if that fails for whatever reason, you can reject the request, and you can do that and basically retry up to over an hour before Forge is going to get sick of retrying for you. You can also do things like implement more complex filters inside of the function before passing it onto your remote endpoint. So basically leverage the Forge platform to perform more of that processing for you. So here you could go back and implement support for JQL queries or JQL filtering instead. And it's just a JavaScript runtime, so you could actually implement filters of arbitrary complexity here. You can also go and hit the product APIs from your Forge function if you want to go and enrich the events before you pass them onto your remote. This also takes advantage of the fact that the Atlassian FAS is probably closer to the Atlassian product API edge than your Connect app is. Maybe not always the case, but so it should be slightly more performant as well. And that also saves you from having to make more API calls back into the product APIs. It also potentially means that you don't need to get bearer tokens sent to you as well, which can have a slightly better security implication for your app as well. And if you want your event handling even more resilient, or if you want to prepare yourself in case your backend that's ingesting the webhooks is going to be down for longer than an hour, then you can potentially go and write those events out to a Forge queue, or even persist them in Forge storage to make sure you're not dropping any of them. And then you can send them out once your remote is stable and ready. So speaking of retries, one particular context to be aware of with this feature is installation event triggers. So when your app is installed, we will trigger an installed event if you've subscribed to it in your Forge manifest. But the Atlassian account associated with your app is granted a set of permissions for all of the domain objects in the site that you're being installed into. And so this is particularly a problem that we see with large Confluence sites or large Jira sites. If there's a lot of projects or a lot of spaces, then your app will be installed, your app user will be provisioned, and then we'll start assigning lots of permissions to that user to be able to write to these different containers. And for a relatively small Confluence site, that can be instant. For a very large Confluence site, that can take up to minutes. And so what we've seen is that if you're making a call authenticated as the app user inside of your install hook, it can potentially fail. So if you're following this pattern, it's always best to check for an authentication error. And then if you hit an authentication error, basically go back and retry it. Now, I haven't seen this take longer than minutes to provision, but if you want to get really resilient, you could go and push that onto a queue instead. But I think generally this should be relatively safe. To be honest, I suspect Atlassian Connect probably has the same problem. I just haven't actually seen it in the Connect app yet. So speaking of queues, let's chat a bit more about how you can use them in a hybrid Connect and Forge world. So if you haven't used a Forge queue before, it's very similar to an AWS SQ. In fact, it uses SQS under the hood. In your manifest, you define a queue name and a consumer function, and that function pulls jobs from the queue and processes them. And then any function you have deployed can push jobs to that queue using the Forge events package. We often use the words, as I mentioned before, consumer and async functions interchangeably. Apologies if I'm a little inconsistent as how I refer to them, but they're the same thing. So we don't support specifying a Forge remote endpoint directly as a consumer, but since a consumer function is just a regular Forge function, you can still use the invoke remote command to call out to your Connect backend. A Forge remote also can't directly push jobs into the queue via an API, but a common workaround is to register a web trigger and then ingest events via that web trigger. So if you haven't used a web trigger before, it's basically a mechanism for exposing a Forge function as a web endpoint. You can use them to build external APIs for your Forge apps, which is pretty handy, or you can use it to ingest data from external sources as well. And it's a pretty decent workaround to allow your Connect app to talk into the Forge app. Now, there are a couple of things to know about async functions. The first is that they have a longer timeout by default than most Forge functions. So most Forge functions will time out after 25 seconds. An async function by default will run for 55 seconds, but you can increase that now up to 15 minutes using the timeout seconds property. We've also introduced a new property in the getAppContext library function that tells you how much time you've got remaining as part of your function invocation as well. So if you're using a queue, you can use that to figure out how much time you've got before your function will time out. So typically, you'll kind of loop through a set of items in your queue consumer, and then once you're getting close to time, you can push whatever items you have left to process back on the queue. Now, the next one's quite a big gotcha. Queues in Forge are not FIFO, so they may actually be processed in parallel, which means we don't guarantee ordering. So when you push a series of jobs to a queue, we'll actually spin up multiple instances of the same consumer function to pull those tasks down. Did that surprise anybody? Yep. But you're not running out of the room to frantically fix the app? No, okay, good. No. So thank you for your honesty. Yes, this definitely was a bit of a gotcha for me as well. So this is actually pretty good for throughput. But if you're not expecting it, it may not always be desirable behavior if you were hoping to chunk through those jobs in a sequential fashion. Now, there is a pattern you can implement on top of a Forge queue to guarantee ordering. It's not the prettiest thing in the world, but it works. So typically, the contract when you push a set of jobs to a queue is to push an array. Instead, what you can do is just push a single giant job with a queue of things that you want to process, and then have your consumer function basically pull that array out of the payload, and then process a number of those items, and then push the remaining array items back onto the queue. So you effectively only actually have one task on the queue at any given time, which means there'll only be one instance of your consumer function running, which effectively means you have serial execution. As I said, it's not pretty, but it works. The only limitation here is that you can only push a maximum of 200 kilobytes to the queue in any given invocation. So if you have more data than that to process, what you can do is write that data out to Forge storage and then push a set of identifiers to the queue instead. And then that way you can effectively chunk through large amounts of data. Yes, we are evaluating FIFO queues, but not currently on the roadmap. Happy to chat more about that if you're interested. All right, so we've covered event triggers, async functions, but now I want to touch quickly on scheduled triggers. If you haven't used them previously, they're a mechanism that allows you to invoke functions periodically. It can be weekly, daily, hourly, and just recently we released support for every 5 minutes as well. Just like other functions, your triggers can interact with your Connect backend using invoke remote if you're running a scheduled trigger via a function. Or you can cut out the middleman and define an endpoint in your manifest, and we'll directly invoke that on a schedule for you. Now, you might look at that and be like, that's pretty silly. I can run cron. Like, why would I want Forge to run a schedule for me? And generally, you'd be right. Like, if you're running an external service, it's pretty easy to schedule tasks. But there is one very important use case in the context of Forge Remote that this is super useful for. So if your remote service needs to call back into the Atlassian Cloud APIs or into Forge storage, and you're subscribing to that app system token property, so you get bearer tokens delivered to you, typically we'll only give you those tokens when a user interacts with your app. So if you get an event or if they go and use a UI module, then you'll be able to get that bearer token out of the header. But what happens if a user doesn't interact with your app for a period of 4 hours, which is how often these bearer tokens expire? Well, to work around that, what you can do is use a scheduled trigger to get access tokens, or bearer tokens rather, on a schedule. So the most common pattern is to set up a scheduled trigger to run every hour and subscribe for the app system token. And then that way you get a new 4-hour token delivery every hour, and you can cache that token and use that to authenticate requests back into the product or Forge APIs. So that means you'll always have a live token in order to be able to authenticate. All right, how are we doing for time? Ooh, terribly. I think I'm already 5 minutes over. But okay, let's. Thank you for bearing with me. We're going to breeze through the migrating UI section, and then we'll. Yes, if you have any follow-up, happy to chat more. I think Mel is running a UI kit workshop tomorrow. Maybe. Yes, excellent. I'll be there. It'll be fantastic. So in Forge, we have 2 UI technologies: UI kit and custom UI. UI kit is a declarative component-based UI framework that wraps Atlas kit. For new features that you're building, if you can get away with using UIKit, it is the simplest option. If you haven't tried UIKit since May last year, definitely go and check it out. UIKit 2 is completely different to UIKit 1 and way, 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 way better and more flexible. Lots of custom styling, lots of cool components. We've got charts. Definitely worth a try. But if you're migrating existing experiences over from Connect, you're probably going to want to use custom UI. So custom UI renders an iframe, just like Connect, but it lets you use your own custom HTML, JavaScript, CSS. You can basically bring over your existing assets from your Connect app and serve them from the Forge CDN instead. Even better, we also have just introduced well, actually not just, it's been around for a while now. We have a frame component that actually lets you blend the best of both worlds. So with a frame component, you basically have a UIKit app, and that tends to provide the Chrome of your app experience. And then you can have a frame, which has a custom iframe that contains all of your custom static assets. Now, one important limitation of this, though, is that we only support a single frame per UI module today. So this works really well if you've got just a section of your app that's a rich experience that needs to be super custom. If you have multiple regions of your app that need to be very custom, then you probably just need to go custom UI for the whole experience. All right, last complex diagram for today, and this one gets pretty hairy, I apologize. We're going to have a quick look at how Forge UI technology compares to Connect. Because although there are some similarities, there are a couple of really important differences that are important when you're thinking about migrating UI elements over. So the Atlassian Connect framework, as I'm sure you all know, renders an iframe targeting your Connect backend and signs that with a JWT using your shared secret so that apps know that the request is legitimately coming from an Atlassian product and that users aren't spoofing the context. Then your Connect backend can also mint its own JOT tokens using the shared secret and use those to authenticate with the product APIs. Then, of course, in the Connect iframe, we also support the AP library that lets you make client-side request calls, effectively piggybacking off the user's session to hit the product REST APIs. So in Forge, this is quite an important difference that doesn't impact all partners, will impact some partners depending on how you've architected your Connect app. In Forge, the UI is still iframe-based, irrespective of whether you're using custom UI or UIKit 2. The fact that it's an iframe doesn't matter in UIKit 2. It does matter quite a lot in iframe in custom UI. So instead of targeting a backend, it actually targets the Forge CDN. So when you deploy your app, we bundle up your static assets, or you can bundle up your static assets, and they get deployed to a CDN, and then we serve that as the target of the iframe, which actually mitigates whole classes of security vulnerabilities. But it does mean that Forge apps are single-page applications from a front-end perspective. So that does mean that you can't use server-side rendering in a Forge app. So if you're considering preparing your UI for migration over to Forge, and you're using JSP or Handlebars or any other server-side rendering technologies, the first thing to do is to start migrating to a single-page application for your user experiences. Just like Connect, the Forge app can make requests to the product API directly using the Forge bridge. So the Forge bridge is more or less functionally equivalent as the AP libraries in Connect. And the Forge bridge also lets you make requests to your Forge backend. So optionally, when you deploy a Forge UI module, you can specify a resolver function that then acts as the backend for your app. And you can use it to make requests to Forge storage or call out to remote sources if you need to. And that resolver is completely optional. You can just have a static front-end app that just talks to the product APIs if you like. And this is where it starts to get really hairy. You can if you're migrating existing Connect user experiences over to Forge, you also have the option of specifying a remote endpoint as your resolver. So that means when a user interacts with your front end and you call invoke from your Forge front end using the Forge bridge, it'll actually make a request all the way to your Connect app endpoint instead of going to the Forge FAS, which is super convenient if you're porting over logic from your Atlassian Connect app, if you don't want to go via the FAS. Or, if you prefer, you can take a similar hybrid approach to what we looked at with some of the other modules. So that Forge resolver function can also use the invoke remote method to call out to your Connect backend when needed. I'm really sorry about the complexity of this diagram. I know this looks really complicated. It's actually very simple in practice. This, from whether you're using custom UI or UIKit, the actual call you need to make in order to invoke either your remote backend on your Connect app or via a Forge function is just that one line. So it's pretty straightforward. Forge handles all of the authentication for you. Okay, so a few things to keep in mind if you are looking at migrating UI from Connect to Forge. As I mentioned before, Forge is unlikely to ever support server-side rendering. If you aren't already, it's a good idea to start thinking about migrating over to a single-page application model for your Connect views. The other is, as Sean mentioned in his great talk this morning with Carol, is that Forge modules may differ a bit from Connect modules. We're aiming for use case parity, not necessarily 100% one-to-one module mapping. Although for the most part, most of the really popular modules in Connect are pretty faithfully recreated on the Forge platform. But that does mean you should plan carefully and start thinking about the user experience when looking at migrating between the two. There's a really good page at, sorry for the layout, go.atlassian.com/connect Forge modules, which has a module comparison between the two different platforms. And happy to discuss different solutions and things like that if you want to look at it together over the next few days. Finally, there is also a bit more work required for modules that require user configuration. So if you have a macro with macro parameters, or a dashboard gadget with gadget configuration, or things like workflow modules in Jira, all of those have some user config that need to be ported over from Connect to Forge. We have a pretty great migration path for all of these modules. I won't go into them today. It's probably another whole talk topic. But if you go to go.atlassian.com/adoptforge and go to the migrating section, then it's got great docs for all of those with examples. Okay, thank you very much, everybody. I'm hoping Oh, sorry, do you mind if I just, I had one more thing I wanted to say. What I'm hoping to do is build like a bit of a library of these different patterns from adopting Forge from Connect. Most of these patterns have been hashed out with partners over the last few months. Thank you very much to anyone from Adaptivist or Tempo or AppFox who've been working with over the last little while. If you've got some cool patterns of your own that you'd like to share, I'd love to catch up over drinks or chat about them in the modules. In the modules. In the workshops over the next few days. But thank you very much for an awesome Atlas camp, and I hope you all had a great time.